Hello, this is checkpoint 2.50, and they want us to find an angle between two planes. So if we imagine drawing these planes, say one plane looks like something like that. There's another plane. Maybe it looks something like that. Well, kind of get the picture of how the planes might look like. There's a line of intersection. When two planes intersect, they intersect in a line, but we're more concerned about just the angle between them. So let's say the plane has a normal vector. One plane has a normal vector that goes like that, and the other plane has a normal vector that goes like that. And the angle between them, the angle between the two planes would be exactly the same as the angle between the two normal vectors. So it's just a matter of finding the angle between the two normal vectors. For one plane, it looks like the normal vector, we'll call it n sub 1. The normal vector should be 1, 1, negative 1. And the normal vector for the other plane looks like, I'll call it n2, and that is 3, negative 1, positive 3. So those are the two normal vectors for the two different planes, and we want to essentially find the angle between them. So to find the angle between them, if you remember the cosine, the dot product, n1 dotted with n2 is equal to the magnitude of n1 times the magnitude of n2 times the cosine of the angle between them. So theta should equal to the arc cosine of n1 dotted with n2 divided by the magnitudes of each. and then we just get the decimal approximation for that. Okay, let's find the dot product. n1 dotted with n2. That looks like it's just going to be 3 minus 1 minus 3. That looks like it's negative 1. So just a little heads up now that if it's a negative 1, we know that that's going to be an obtuse angle. And if you have two planes that are intersecting and you have an obtuse angle, then that's not the smallest angle between them. So we have to subtract it from 180 degrees, or pi. All right, so that's one part. The others are just the magnitudes of each of those vectors. So let's find the magnitude of n1. That's the square root of 1 plus 1 plus 1. And the magnitude of n2 is going to be 9 plus 1 is 10 plus another 9 is 19. So we have the information that we need to put into the arc cosine function. Arc cosine of negative 1 divided by root 3 times root 19. Alright, so this is basically a calculator work now, and with this I think I got approximately 1.7036. Now again, this is bigger than pi over 2, bigger than 90 degrees. It's obtuse. So we want to subtract this from, so basically what we have between the two angles that we got, that's one normal, this is the other normal, and we found this angle right here. But that's the larger angle, so if we want to find If we want to find another angle between them that's smaller, we have to subtract it from 180 degrees. So the other angle that we want, we'll call it theta, maybe theta prime, should be equal to pi minus 1.7036. So pi is just 3.14, and with this I got 1.44. Okay. All right, I hope that helps.